All right, so as we continue our discussion, we were talking about a different experiment, or we have a different research question. In this case, does marijuana improve creativity in adults? And the hypothesis statement is participants use a marijuana product will produce more creative art than those that don't use this product. And the independent variable has two levels in this case, and the first level is no marijuana condition. The second level is marijuana condition. And what we are measuring is their creative output. And in this form of creative output, we're looking at their artistic ability. So because of this manipulation, we want to see if they will have more creative art than the group that does not receive the manipulation. So let's go ahead and move on to how else it could look like. And I was talking about this briefly in the previous video, where if we add water in one condition, and let's say we add coffee in another condition, and then let's say finally we give the marijuana product in the third condition. And so the independent variable is still one independent variable, but it has three levels to it, three different conditions. So think of levels as three different conditions. And one group of participants will receive water, another group of participants will receive coffee, and a final group of participants will receive marijuana product. And we want to see which group will have the most creative output. Now, of course, we can increase this, and this is a different research question, but it just sort of gives you yet another example of how this can go. So let's say our research question is, does the amount of coffee one drink improve test scores? So we still are in an experimental design, and hypothesis statement is participants that drink more coffee will have higher scores than the other group, or the other groups, I should say. That's plural because we have many different groups. This is more the specific testable statement that we're making, and this is the general question about coffee and improving test scores. And so we have, in this case, group 1 receives nothing at all. Group 2 receives one cup of coffee. Group 3 receives 2 cups of coffee. And group 4 receives 3 cups of coffee. And what we're doing is measuring their test score. And my hypothesis, when I am predicting to happen, is participants that drink more coffee will have higher test scores than the other groups. And in this case, that's what my hypothesis would say, and we would do some fancy statistics in order to figure out whether or not there's a difference between these groups and where specifically there's a difference between these groups, and that will be a later talk. We'll talk about that. But let's say that this group is significantly different than all these other groups. Then our hypothesis is correct, and then we can sort of do a victory lap, and then we can go on with other research projects of ours. So this has, probably should belabor this point, because it has 4 different conditions in this one manipulation. It's 4 different kinds of ways to manipulate the amount of coffee somebody drinks. We have 4 levels. So it's nothing versus the coffee condition versus 2 cups versus 3 cups. Now, I probably should mention this because this is very important. If we are picking a direction to how we think things are going to go in the experiment, in this case, we think that if we drink more coffee, we'll have a higher test score. That's in one direction. One direction being the positive direction. And so if this is the average, we would expect our coffee drinkers would be on this side of the average rather than on this side. So we're going to put all of our support into this hypothesis, which is what we looked at before, which was a one-tailed test. And in a one-tailed test, well, we haven't talked about one-tailed tests just yet, but what I will say is that we have talked about the idea that if we have a score, where our score lies in comparison to the mean. And if our score is significantly higher than the mean, then we score better than the rest of the people in the class when it comes to like maybe a test or quiz performance. In this case, we are saying that the group that receives coffee has the highest performance, and we're putting all of our information in our prediction on the right side because we think this is the way it's going to go. It's going to be in this direction, which is the right tail, the positive side of the distribution. Now, if in fact we do not know which direction it will go, if they drink more coffee, we just think that, oh, in a vague sense, there is going to be differences between groups, and we don't know where that outcome is going to be, where that test score is going to be. So we just say, let's say if we were to change this research question around to, does the amount of coffee change test scores? Now you see how this is a vague question. I haven't given direction to my question. So if this is a vague question and no direction is in this question, then what I would do I would have a two-tailed test because I don't know if it's going to go in the negative direction or in the positive direction. So it could go in this direction here, or it could go in this direction here. I haven't really specified it in my research question. Now, maybe I did specify in my research question, and maybe I think, does the amount of coffee reduce test scores? If the amount of coffee reduces test scores, I'm looking at a one-tailed test again in the negative direction. And so hopefully that's clear, is that if you pick a direction to your research question and the hypothesis statement, then it's a one-tailed test. If you do not pick direction, then it's a two-tailed test. It's automatically a two-tailed test because you don't know if it's going to be a higher or lower score. You just know that there's going to be a difference. And we can see this here, and I was able to make that difference when it came to the research question and hypothesis statement. All right, so let's move on to this example. So this is in the walkthrough as well. A grocery store would like to know whether placing the expensive tomato sauce at eye level would lead to better sales for the product. The manager believes that if she places the jars of sauce at eye level, the placement would in fact yield higher sales. She tests this by placing the jars of sauce at eye level for 1 week and then above eye level for another week. She records the sales for each week and compares. So think for yourself for a moment, like what would be the research question? What is the sort of the overarching question, the big question that's being asked? Now in this case, the answer is right here in these first two sentences. If you can sort of summarize this in one way or another, it will provide you with an answer. And so in this case, would the placement of tomato sauce at eye level lead to better sales? That's the research question. Now, with this research question, we can go into our hypothesis, null hypothesis, and alternative hypothesis. And that's going to require me to skip a couple steps. So my PowerPoint is a little bit like not in order. So give me a second to reorient things. Okay, so now we have the null hypothesis and the alternative hypothesis. And as we see here, the null is the sample mean at eye level condition is equal to the sample mean at above eye level condition. So we have these two conditions here, and we're testing to see if there's a difference in sales, right? So in this case, this is the null hypothesis. There is no difference between the groups. And then alternative hypothesis expresses that there is difference between groups. So that's what we are trying to look to affirm in our research question. And so that's kind of the way things are going right here, is we have either this is going to be true or this is going to be true. Now let's move on to the independent variable and dependent variable. And so again, think about the independent variable as something that's manipulated or controlled. In this case, something that's changing. In this case, she tests this by placing the jars of sauce at eye level for 1 week and then above eye level for the other week. So this is what is changing. Position of the jars of sauce. And you could also say eye level, like where is it in the position, in this case specifically eye level. And the levels of this eye level, what conditions do we have? We have eye level and above eye level. And then what are we measuring based on these two conditions, or these two levels of the independent variable? Well, she tests this by placing, well, the manager believes that if she places the jars of sauce at eye level, the placement would in fact yield higher sales. Sales is the dependent variable. And then we've looked at these two right here when it comes to null and alternative hypothesis. Now, let me ask you this. Would this be a one-tailed test or two-tailed test? I'm going to pause here just so that you can think about it. Okay, so the manager believes if she places the jars of sauce at eye level, the placement would in fact yield higher sales. So notice in this statement, what is being said here? Is there a direction being said here? Well, yeah, if we were to draw this out, we have this normal distribution, and here is the average. And let's just put like a money sign here, right? And what we are saying is that at eye level, there will be higher sales. So we're picking a direction. So in this case, we do have a one-tailed test because it's only looking at one tail, the right side of the distribution, or the right tail. So in this case, one-tailed test is the answer. Now, if she was to say, if this researcher was to ask, the grocery store would like to know whether placing expensive tomato sauce at eye level would lead to different sales, then we could say something about it being a two-tailed test, because different means either lower or higher. And then we would have to change this as well, different sales. Different or vary, that's another way, keyword that's being said. That doesn't pick a direction, it just says there's just going to be some difference, but we don't know the direction it's going to go. All right, so I think I'm going to end up here. And so there's always going to be error in our hypotheses and our experiments. And a type 2 error is going to be a false negative. So you see that there's no difference when there actually is. And the type 1 error is there's a false positive. You see the difference. You see that there's a difference when there actually is not a difference. And we'll go into more detail with that later. But I think I will say that. And of course, we have a little thing called p-values. And check the walkthrough, and we'll talk more about this in class. Thank you so much for listening.